there's another decision making or a control structure available in case of a Unix shell scripting, and which is a case statement. So in our earlier discussion we have seen how to write a simple if, a compounded if, a multiple if else if, and a nested if. Typically, when multiple conditions are to be evaluated, then we generally use the if statement. For example, if it is raining and I have a raincoat, then carry the raincoat. So how many conditions I am evaluating here? More than one. If it is raining is one of it, and if I have a raincoat is another of it. Then carry uh, it with you during the rainy season. So this is what is my multiple condition evaluation. Case statements are generally used in cases where evaluation condition is one, but there are multiple probable alternatives to it. So condition need to be evaluated is one. For example, if month is January, how many conditions I am evaluating? Only one. That is, what is the month? If it is January, then do this. If it is February, then do this. If it is March, then do this. If it is up till December, do this. If it is none of the above, this is called as the default case, then run these statements, which is the default action. When you write an action, the action for a given case match, in case of C it ends with a break statement. Here it should end with a double consecutive semicolons. So consecutive semicolons to mark the end of the case. If you do not put this break statement here, then assume that I have entered month as January, then my program has entered come to this particular level. It says case month in January, it will perform these actions. But since there are no break statement, it will also execute this action. So that break statement is required to end the case matching there and then itself. So when the condition to be evaluated is of the type text, in my case the month variable is of the type text, then as a good practice you should include the text in double quotes, and so are the values, because you never know. I mean, in this case I know somebody is anticipated to enter the month as Jan, Feb, March, which is a single word. But consider that if the input contains a space, then the whole thing will go for a toss. So that's why it's a good practice to include everything in double quotes, because you never know whether or not the person providing the input will provide it with a space or without a space. If it contains a space, then it will become, somebody type, let's say JAN space UARY. Then the whole thing becomes what? Case Jan space UARY in, and it will result into a syntax error. So that's why it's always a good practice. It's not mandatory, but it's always a good practice to include the textual data within double quotes, which acts as a delimiting. So I am delimiting the data with a double quotes. So when the condition to be evaluated is of the type text, then the variable to be examined and the value to which against it you want to match it must be enclosed in a double quotes as part of best practices. So I said if case month in, if it is January, perform the action statements here. So you are free to write whatever you want to write here, valid Unix command. And once you think the probable match is done and you want to mark it as a end of a case match, then mark it with a double semicolon, which marks as a end case or break statement for that particular match. If it is February, then perform these action statements. Again, the break statement which matches the case break. So here it won't go forward. If you don't put this one, assume that this portion is missing, then this will be executed and this would also be executed, which is not the correct thing to do. So let's write down. So I'm saying hash exclamation bin KSH, enter month abbreviated, read var mnth. Then I'm saying examine the value of var month in using a case statement followed by the case matches. I am assuming that the user is typing it all in uppercase. Then I said echo, this is January. It's a winter season. And I am marking it as a end case. Then I said Feb. I am marking it as an end case. When none of the above cases matches, you can put a default case. You must mark it as end, and then the whole case itself works with ESAC, which is reverse case written in a reverse way. Once done, I mark this script as executable, and then I run it. It says enter a month. I said Jan. It says this is January. It's a winter season. I run it one more time. This time I said Feb. It says February. This time I run it. I said something else. Say December. Then when none of the above cases match, then the default case will be a probable match for it. It says you must have typed other than Jan and Feb, and that's why it's an invalid input for my program as of now. So I'm editing my program one more time, and I want to see what happens if I delete this line. Now I check month case.sh and I'm typing the probable match as Jan. See what it says? It's a syntax error. So it says it's syntax error. You must have a match with a break statement. So I'm editing it one more time and I would add back those lines here. When none of the above things would match, then the default case would match. Now it's the same thing here, but this time I am doing a numeric comparison. I am assuming the month was entered as a numeric value between 1 to 12. Then if the value is 1, so you must have noticed here it's included in double quotes. Numeric variables need not be enclosed in a double quote. Here the probable match value was again enclosed in double quotes. Here the numeric value is not included in double quotes. So I said case $month in 1, perform the action statement, the case break. If the value is 2, perform the action statements, the case breaks again. So on and so forth, followed by at the end the default case, followed by the action case statements you want to write for a default case, followed by the default case break, and end of case statement. So understand in which case one should use if. Can't I solve this using a if statement? I can. So I could have said if month is Jan, then whatever. Else if, ELIF, month is Feb, then do this. But if you see how much of the typing is required when I try to attempt the same program with if, else if, it's much more. So the program becomes unmanageable at some point in time. So when you have one condition to be evaluated against multiple values, the suitable control structure is a case statement. So condition to be evaluated is 1, but the values are many. Then in such cases you should make use of case statement. And when is if appropriate? when there are multiple conditions to be evaluated, then in that case if is more an appropriate structure. Although it's up to your own, it's your own uh, prerogative programming style, that whatever you feel suitable then you can make use of it. But I am telling you, which this makes my program more readable with a case statement instead of writing multiple if else if statements. I already talked about arithmetic expression. Whenever you want, by default all the variables in Unix are treated as if they are text. So even if the value to assign to a variable is a numeric value, that it will still be treated as not a number 10 but a text value 10. And we have already seen what happens when you sort a file that contains number but you don't indicate that it's a numeric sort. It will try to sort it as if it's a set of alphabets. Now when you want to do an arithmetic expression, you must indicate the purpose using the expr command. So which says evaluate this as an expression. By expression I mean an arithmetic expression. So I said evaluate this as an expression, number 1 and number 2. The whole thing was included in backtick, which acts for command substitution. So the command would be run, the results instead will be put here. Then my echo command becomes, let's say number 1 was 2, number 2 was 2 again. So I said 2 plus 2 is equal to 4. The first thing it will do is to evaluate this expression since it's enclosed into a backtick, grave accents. So it will run this, it will make it as 2 plus 2 as 4. Since it's part of the command substitution, the whole value, outcome of that expression will be substituted. My final statement then becomes echo in double quotes 4. So it will simply print out that value because you have included it in a command substitution. Then I told you what happens when you use a multiplication operator. I have to suppress this thing because by default multiplication, that asterisk symbol which is used as a meta character in Unix or the wildcard character, by default star means all the files in the current directory. So it would have become multiply number 1 or evaluate the expression number 1, all the files in the current directory, and number 2. So to suppress the special meaning of that meta character asterisk, you are suppressing it with a backslash, or also called as an escape character. So that escape character will suppress the special meaning of that wildcard character's asterisk symbol and instead will force the use of that asterisk symbol as if it's a multiplication operator. So the precedence is plus, minus, or these are the arithmetic operations one can perform. Let's not worry about the precedence. Plus, minus, multiplication, division, and modulus. So it will tell you the remainder of something by something. What is the remainder of the division? Where file name is as good as saying dollar into curly brace this thing. So see how one can refer to a variable. So I said x is equal to pu, y is equal to ne. I have defined two text type of variables. Then I want to display echo $x, $y. It works. Clear? It works. It will also work if I say echo $x, $y. What is the difference here and there? Here I am categorically delimiting the variable using a curly brace. Now people say, why do you need to delimit? So understand here. I said echo $x ne. So what I am saying? $x will put what? Pu, and then I am appending to it ne. See what happens. Is this what you anticipated? No. Actually, you were expecting it should print the value of $x. $x is pu, and further to it I should be able to append any, which is a text string. So it should, whole thing should be pune, right? Which is not the case here. That is because it is expecting now in this case that the variable is xne. Is this a variable? Variable part is only x. Any is the static string literal that I want to append to the value of the variable x. In such cases, delimiting of the variable comes as a handy technique. So this time there is no problem. So I said the variable is actually $x, which is delimited by a curly brace followed by any. So it appends to the value of the variable $x any as a string literal, which then prints pune. So see what I mean by here. $var file name, which is a variable, is as good as saying dollar curly brace var file name curly brace. Which is the better of the two techniques? This one is better, because it avoids the ambiguity, especially when you are appending. Because in this case, here the variable has been delimited by a curly brace. In a general life, it does not make any difference. So see here, I said name is equal to Satish, and then I say echo $name or echo $name. It's one and the same thing. So in a general usage case, it does not make any difference whether I print $name or curly brace variable name curly brace. But it will indeed make a difference if I want to append to the variable's value. So for example, if I wanted to append, see what it says. But if I wanted to append here, it does not have any problem. Clear? Because the variable has clearly been delimited within a curly brace. So it tells Unix that this is the name of the variable. Instead put the value here, further followed by the other text literal that I want to append to it. In this case, it was assuming that the name of the variable is name lodem, which is not the case. The variable is only name, and LODAM is a text literal to be appended to it. So as part of a standard naming convention, try to follow this convention. So even when in a real life you come across a situation of appending, you never run into issues. So don't follow this as a standard practice, this one. Instead follow this as a common practice. There will be an extra typing every time you type a variable value by putting a delimiting curly braces at the beginning, at the end. But it's always a good practice to use it. If I say $var file name this thing, the variable name is delimited by curly braces and is thus separated from the outside world. Now what I mean by outside world? This thing. So I said f name is equal to exit status. So I say echo $f name. Now to this I wanted to append txt. It's not working. Now but the whole variable, if I include it into curly brace, it works. Clear? So try to delimit a variable. It makes the program readable and it's always a safe programming practice, because even if you append, it won't lead to any ambiguity. You can define a variable something like really long running variable. Now if I want to print the value, you can say dollar, as part of our new convention, include that whole thing into curly brace. It prints the value. What if I want to print the length? Then in the curly brace, just prior to the variable name, include hash. it will print the length of the variable's value. So if I say, so I will count how many characters are there. 4, 5, 6, 7, 8, 9, 10, 11, 12. Now instead if I say in curly brackets hash, see what it prints? It prints the length of the value assigned to the variable f name. So this could be one of the handy techniques while you want to find out, because remember in SQL you have len gth function, len or length, which gives you the length of a column's value. In Unix shell script there aren't any header libraries that provides you ready-made functions. So these quick techniques can come handy while you are writing the shell scripts. So when you say echo dollar in curly brace hash followed by the variable name curly brace ending, it prints the length of the value assigned to the variable var text. In our case, I believe it printed 54. So if you start counting this value, it will be 54 characters, obviously excluding the double quotes. So double quotes are not counted as part of it. I believe we have already talked about head and tail. Head displays you the top lines and tail displays you the bottom lines of a file. If not, did we talk in the class or not? So I'm running a long running file. This is line 1. This is line 2. This is line 3. This is line 4. This is line 5. This is line 6. This is line 7. This is line 8. This is line 9. This is line 10. This is line 11. This is line 12. So I have created a 12 line file. Now see what a head and tail can be used for. Head followed by file name obviously displays the first 10 lines by default from the given file. Remaining lines will not be borrowed. So people say, what if I run it on a file that has only 5 lines? How could it display me the top 10 lines then? So it will not borrow remaining lines from elsewhere. So see here, I said head followed by the file name. See how many lines it displayed? Only top 10 lines. If you want to display any more or any less than the default top 10 lines, then one could use head -5. If I wanted to display more or less than 10, I said 11. So it's displaying how many lines now? First 11 lines. By default, when you do not print anything, it will display only top 10 lines by default. If you don't want to display all top 10, you want to display any more or less, then include that as a number in the head command as an option. Opposite to head is tail. Tail displays last 10 lines by default from a given file. So if I say tail, it displays only last 10 lines. See here, 1 and 2 was not displayed. Remember there are 12 lines in the file. So it started displaying from the end only 10 lines. If you want to display any more or less, then like head, you must tell this. See here, last 5 and last 11 lines respectively. Now there's an interesting thing about a tell command. I can use tell with a hyphen f option on the file. See what is the default behavior of tell. It will display me last 10 lines from the file, but since I used F is the follow option. Follow means as and when text is getting appended to the file, it will display me a running commentary of it. It won't terminate and come back to the command prompt after I type this command. See here, it never returned to the command prompt. It is still waiting. Waiting for what? As and when commands are getting, text is getting added to the file, it will keep on displaying me. So let's say so I said echo what I am doing here. What does this means? Append. I said append this line to the file. See what happens here? It is watching that tail growing. So it's called as hyphen F is follow the tail. So follow the tail of the file. Now people say, why would I follow a tail? Typically you will run some programs. Those programs would generate some log files. You would typically run a tell hyphen F on those log files to see what is getting written in the log file of a program while the program is being run. This is to troubleshoot a given problem. What happens when I run a program? What messages it typically writes in a file? So again I am saying see there, follow the tail. On this screen what's happening? Clear? Once I am done with enough of my observation, I must terminate the command by pressing Ctrl C. So understand the behavior of tell hyphen F. Tell by default will display 10 lines, last 10 lines, and then it will keep on following until you press Ctrl F. Now what if I don't want to display last 10 lines? Then you can say 5F, which means display the last 5 lines and keep on following. See here. So it didn't display this time 10 lines. It only displayed a limited ones that you have mentioned. So tell hyphen F file name keeps track of the tell of the file as the file gets appended. Hyphen F stands for follow the tail. Sometimes in your shell script you may want to capture attention of the data entry operator or the person who is interacting with your program, because it's a warning or an alert that you want to flash. But remember, I am working all in a black and white window by default. That black and white window has no provision to give a pop-up, a bell or a sound. Then how do I capture the attention? Typically this happens when a critical input is required and the job of a data entry operator gets monotonous. Example, these are the questions which I am asking monotonously and my program is of the type interactive nature. So I said, are you a human? He said yes. My question was, are you a human being? Then it says read input. He said yes. I said, are you still alive? He says yes. I said, are you hungry? He said yes. I said, do you want to become rich? He said yes. I said, do you want to die? He said yes. Remember, I asked him a very important question. But in the monotony of typing the input, the question was skipped. There was no highlighting, danger sign. This is a critical input that is required here. So there was no danger sign here. So how do I grab an attention for some critical questions being asked? Then You must have something flashing on the screen. There must be a sound. There must be a siren. Something that makes my user alert that the next input is really a critical input. So see here. Then you can begin the reverse video printing. Reverse video is a exactly opposite of what your window appears. If my window is black, text is white, then in a reverse video, the background will be white, text will be black. But in my case, I already reversed the video. My background is white, text is black. If I enable reverse video here, the background will become black, the text will become white. Exactly the reverse video. So see here, I am enabling the reverse video effect. I said tput SMSO. Tput SMSO, begin the reverse video mode. Then I said echo. I am removing the reverse video effect now. Tput RMSO. And I am getting the input. See what it says. Now it's in a reverse video. It quickly grabs an attention in a monotonous data entry environment. It says, say yes if you want to die now. I said, no, I don't want. If in the absence, if you would have done it, see how it would have appeared. So I don't get this is as a special question. So it's like enter yes, enter yes, enter yes, enter yes. Do you want to die? Enter yes. So which makes it as a very monotonous data entry. Now the moment people know this, they start flashing now. The moment you know this technique, and this is where it defeats the purpose of this flashing. If you start flashing every now and then the purpose of flashing itself gets defeated. When should you use flashing, reverse video effect? Only when there is something critical that you want to capture an attention for. For example, type yes if you want to delete all files. Now assume that he is in a night shift, he is working, he is not reading it properly, and he says in the same screen, if he gets type yes if you want to delete all files, he said yes. All files got deleted. Now he also realized that he shouldn't have typed yes, but your program is so monotonously written that it never gets a critical input by asking that brain to tickle. The brain should tickle at some point in time because it's a critical action. Now when you want to flash some important messages, flash them in a reverse video mode so that it quickly grabs the attention of the person saying this is something very dangerous. I would have typed here yes because it was in a monotonous set that it asked me in a monotonous tone. So understand, to start beginning the reverse video, type tput SMSO followed by the message that you want to print. Followed by end of the reverse video effect. If you don't end the reverse video effect, it will continue forever. See here. I simply started the reverse video. Now everything is in the reverse video. Whatever I type, even for that matter. Echo. Hi there. Clear? All black. Well, I am not racist here. I am just trying to play it on a lighter vein. Otherwise, people would say you are racist. You are saying that it's a black. No. Well, I want to get back to the other color. I won't call it as white because my screen has been deliberately turned into white so that it becomes easy for you to read. The moment you say tiput RMSO, it removes the reverse video effect. Now whatever you type will come in a regular text. So enable the reverse video effect, print your message. The moment the message is printed, disable the reverse video effect, because until you disable, it will continue to print everything in a reverse video effect. Well, at some other point in time, I already talked about running the commands in the background. So that's all from this particular text that I wanted to discuss. Now we'll fresh start a discussion with respect to Unix shell script. There's another way to accept input from the user. Normally, whenever we want to accept input, we think of only one technique, that is interactive execution. That interactive execution means you will raise a question and the user is supposed to type a response to it. So you will say enter your age, he will type the age. You will say enter number 1, he will type number 1. You say enter number 2, he will type number 2. But such interactive programs at times could be a big liability on your organization. Now consider a case that I want to run a backup of my database every night and I have written the program in an interactive manner. Said the programs could be a big liability on the organization if they are interactive. See it this way. There is a way I wanted to do a backup of my database, say Oracle database, and my programmer or whosoever has written this script has made it interactive. He says enter the name of the database, enter the type of backup you want to perform, enter the location of the backup where the backup file should be kept. The whole thing has been written in an interactive manner. So how many questions it asks? 3 questions. Which database to take a backup of? What type of a backup to perform? Let's say in Oracle there are 2 types of backups. A hot physical backup and a cold physical backup. So it expects the second question to be hot or cold. Should be the response to that question. What type of a backup you want to perform? And the third question is, which is the directory where the backup file should be kept? The whole of it was written in an interactive format. It asks a question, user types an answer. It asks a question, you need to type an answer. And then once all 3 questions were asked, 3 responses were provided by the user, the script performs the necessary action on that database. That is to take a backup. Assume a case that a backup runs for 4 hours. And I am supposed to take this backup every night at 1 AM. But this whole script has been written in an interactive manner. That means every night at 1 AM, I need to have somebody in the office to run it. It will ask 3 questions. He need to type 3 answers and then head back to home. Because his job is done. For next 4 hours, the backup will run. So is there a real need for interaction in this case? What if I want to remove the interaction part of the script? Solution is pass all the values that a script expects as command line arguments. Command line arguments means along with the shell script name itself, pass whatever inputs are required by the shell script. Obviously, I will have to remove the interaction part of it. So for example, let's reconsider add.sh program. So here was my add.sh program. Assume a case that I am supposed to run this add.sh program every night at 1 AM with whatever values I want to provide. So I said 4 and 5. So the program will do anything, whatever is the logic given into that program. But the problem is the interaction part of it. So it prompts me enter number 1, enter number 2. What if I want to make it non-interactive in nature so that I can schedule it? It does not prompt for any input from the end user in that case. So I am removing the interaction part of it. I am now saying copy add.sh to non-interactive add.sh. The name is just non-interactive to indicate the purpose. Now I will remove the interaction part of it. So I removed the interaction part of this thing. Whatever numbers I would provide directly on the command prompt itself. But then there must be a provision in your script to handle those command line arguments that the end user is passing to it. The first command line argument can be accessed with a special variable in Unix called as $1. $1 is the first command line argument that you pass. Well, I should have said here $2. The second command line argument can be accessed from within the shell script using $2. So whatever was your $varnum1 now is $1. Whatever was your $varnum2 is now $2, assuming I am passing those as a command line arguments. So once done, I am saving this, marking this program as an executable. See what happens now. I said 4 and 5. Along with the program itself, I have passed those two numbers to be added. See what it says now. So how did I access 4 from my shell script? Using the positional parameter $1. How did I access the second command line argument to it? By saying $2. So on and so forth. So understand this. Normally, the input required by a shell script is obtained from the user in an interactive mode. But then I told you what is the problem. Now every night at 1 AM I need to have a person sitting in the office to run it and to give those inputs. What if instead I can mark it as a non-interactive one? The system prompts for the input. Such programs has a strict dependence on the user, meaning you cannot run that interactive program in the absence of the user. So if my user is not there in the office, my backups will not run now. So what if I try to remove the user interaction part from the script? But certain scripts which are frequently run as a scheduled job can be scripted in non-interactive mode. The necessary input required by that script can be passed directly as command line arguments to the script itself. A typical shell script, say for example backup.sh, accepts command line arguments and can be then run as where to take what is the name of the script, which database is the one that you want to take a backup of, what is the mode of the backup that you want to perform, hot or cold, and what is the backup location, where should be the backup kept. If I was supposed to prompt it, there would have been 3 questions. Enter the name of the database, enter the type of the backup, hot or cold, and enter the location. Instead of making it interactively, I have scripted it in such a way that what is the name of the database? $1. What is the type of the backup I want to perform? $2. Where I want to perform the backup? $3, by passing them as command line arguments directly to the shell script on the command prompt. Later when I want to cron it, schedule it, I will schedule it like this. So I would have scheduled this at night by saying all these parameters. Now understand, with respect to command line arguments, what are the special variables? If in a shell script you write $hash, it means print the count of command line argument. What is the count of command line argument here? 3. First, second, and third. $* prints the command line as is. Whatever you have passed on the command line, the script will print it as is. Means my output would be my DB, hot, and whatever is the location. It will print the entire command line as is. If I say $0 from the script, $0 is the exact name of the program that you are running. This is $0, this is $1, this is $2, and this is $3. $1 would print the value of the first command line argument. In my case it is mydb. $2 will print the value of the second command line argument. In my case it is hot. $3 would print the value of the third command line argument. In my case it is this. If I say $4, 5, 6, 7, 8, 9, it will not print anything, because there aren't any command line arguments for 4th, 5th, 6th, 7th and 8th and 9th positional parameters. So it will all print null, because those parameters are not passed to the script. So you can access the command line parameters from $1 to $9. So $1 first parameter, $2 second parameter, so on and so forth up till $9, which is the 9th parameter. Then immediate comes a question. What if there are more than 9 command line arguments? Can't I access it? Answer is yes, but not directly using a variable called as $10. There is no variable called as $10, 11, 12. There is some other technique that we will revisit at a later time. So consider a case. I said #bin ksh. Your program name is, how can I access the program name? Using special variable $0. So on and so forth up till 9. If there are 9 arguments, you indeed pass to the program at the end. $* prints the whole command line as is. $# would print the total number of arguments. Now I am running it. I would only run it with 3 command line arguments. See what it says? The name of your program is the way exactly I typed it. Right? This is accessed using $0. The first command line argument is, the second command line argument is, remember 3rd, 4th, 5th, 6th, 7th, 8th I never printed. 9th command line argument is null, because there aren't 9 command line arguments to it. The command line looks like Pune, Mumbai, Pune. The total number of arguments are 3. Remember, all these are special variables. Now this is one more addition to our list of special variables. So earlier we knew $? Prints exit status of a command. $! Prints the PID of the last job that you submitted for background execution. $0 in case of command line argument, it prints the name of the program. $1 to $9 prints the positional parameters for command line argument number 1 to 9. $# prints the count of command line arguments. $* would print the exact command line as is. As is, it will print the command line. So all these are special variables in Unix. There is one more. I said PS. Then I am saying echo dollar dollar. So what dollar dollar prints? PID of the shell where the command was run. So where was my command echo dollar dollar run? In the command shell bash, which has a PID of 4073. So these are all the special variables in Unix. So they would typically ask you in interview, tell me what are the special variables in Unix. So you should be able to count dollar question mark, dollar exclamation, dollar dollar, dollar zero, dollar one, dollar two, dollar three, dollar four, dollar five, dollar six, dollar seven, dollar eight, dollar nine, dollar star and dollar hash. There's one more. Dollar at the rate. See what dollar at the rate prints? So dollar at the rate and dollar star are one and the same thing. Dollar star also prints the command line as is, and dollar at the rate also prints the command line as is. Clear? So these are special variables in Unix. You must be very much sure about it. What is the meaning of each one of them? Now let's write a program to accept the name of the person and then print a message. Two things. Let's write a shell script to accept name and age and then print a welcome message saying, if I type say, and then I type the name as Tom and age as 29, it should print me a message, welcome Tom, your age is 29. Clear? Let's write a shell script. What should I write? I want to display the message. So I said echo welcome Tom. Tom is $1. Whatever I pass as a $1. Your age is $2. Right? Everyone agrees with this one? So understand now the problem. Now when I run this, I say Tom 29. Looks correct? Welcome Tom, your age is 29. Now see here. I said name is Satish Lodam, age is 29. See what it says now? Welcome Satish, your age is Lodam. Is this correct? What is the problem? For me the name is Satish Lodam, but for Unix shell script, Satish is $1, Lodam is $2 and 29 is $3. If you want to override you should have said double quotes. See what it says now? So what is $1 in this case? Satish space Lodam is $1. And what is $2 now? 29. So whenever you want to override a space, you want to treat this whole thing as input number 1, then you must include it into double quotes so that it is treated as $1 and not as $1 and 2. Clear? So you always be wary about these techniques. So because you never know, an end user may type, he was given a manual saying you are supposed to type the name as the command line argument number 1 and command line argument number 2 should be your age, and see how the program runs. Typically a tester, the tester who performs the QA test on a program, he would be running it with random inputs. He would say my name is indeed this one, and then my program goes for a toss. So whenever this is the case, your manual must say if the first or any of the command line input includes a space for a given response, the whole response should be closed in double quotes, should be enclosed in double quotes. Otherwise the program will go for a toss. So you are supposed to take care of these command line arguments throughout your program. Well, now what if I want to add a set of numbers passed as a command line argument? You know what is the problem with this one? This is my $0. This is my $1. This is $2. This is 3. This is 4. This is 5. This is 6. This is 7. This is 8. This is 9. I don't have any problem up till here. How do I access command line arguments beyond the 9th positional parameter that has been passed on the command line? Because I told you there is nothing called as $10, 11, 12, 13, so on and so forth. That's where the command line would make my life difficult. In this case, you can make use of shift command in your program code. Every time you use a shift command, the positional parameters would shift by one position to the left. What I mean by this one? See here. I am writing it here now. If this is my program, if I say echo $1, what it would print? 10. If I say echo $5, what it would print? 13. If I say echo $9, what it would print? This is 6, 7, 8 and 9. It would have printed me 200. Now I can't access any number beyond positional parameter 9. Now see, if I type a command shift, what would happen? Well, if I type echo $hash, what it would type? $13. Because there are total 13 arguments to the program. Now after this, if I type shift and if I rerun in my program code, the same thing. Shift will shift it by one argument position to the left. So see how it will appear. My command line after I type shift would be something like this. See here what it has done. It has shifted the whole command line to the left by one position. By one position means by one argument at a time. So 10, which was the leftmost argument, the first argument, was removed and the whole of it got shifted to the left. Now if I say echo $1, it will print 11. If I say echo $5, it will print 15. If I say echo $9, it would print 18. If I say echo $hash, it will print 12. If I use in my command one more time shift, it would be like this. If I retype this in my same command or shell script, $1 will become 24. $5 will become 19. $9 will become 19. And this will become 11. So every time you use a shift in your program, the positional parameters will be shifted by one argument position to the left. People say, is there a reverse shift to get it back? Answer is no. Once it has been removed from the command line using a shift operator, there is no way you can put it back onto it. It's like a conveyor belt in a assembly line, a mechanical factory. That conveyor belt carries items from one packing unit to another packing unit. Once the element has been dropped out of a conveyor belt, there is no way I can reverse rotate that conveyor belt back to its normal position. So let's write it here by saying too many cmd arguments .sh. I said hash exclamation bin KSH, and then I am simply typing my program. Right? This is what my program is. So I said echo shift, and again echo shift. Well, last shift is not required. Good enough for our observations. Now I run it by marking this as an executable, and then I say I would pass my original command line to it. Well, I didn't say echo. Did we? The problem was this. This got copied. Done? Now I run this. 10, 13, 213. Right? 11, 15, 18, 12. 11, 15, 18, 12. 24, 19, 19, 11. Clear? So every time you type a shift, the positional parameters will be shifted to the left, and the hash, $hash count will also reduce by 1. Now, why I am talking about this one? Now it gives you an idea how you can access beyond $9. Now I can always access beyond $9. So until my command line has arguments, I will keep on shifting them. So I will shift as long as there are arguments available. And at one point in time, I would use those many shifts that there aren't any numbers left on my command line. And this is when I can do an addition of it now. But the problem is, how do I do these actions iteratively? I don't know how many command line arguments you are typing. So I can't use X number of shifts. That X is still a guess. So I knew here that there were 13 command line arguments. So I should type 12 or 13 times the shift command. What if the number of elements to be passed on a command line are not known? This is where loops, iterative actions, can help you make a controlled execution of a program. A loop is a technique in programming which allows you to run iterative actions. Iterative means repetitive actions. Say for example, see what I am doing here. At the beginning of my program, I have taken a variable called as I, value of which is 1. Then I am making a decision in a while loop. I am evaluating a condition. Is $I less than or equal to 10? As of now, the value of I is 1. Is 1 less than or equal to 10? Yes. Then print what? Print the value of I. It will print 1. Then I am saying I is equal to I plus 1. Whatever is the current value of I am adding 1 to it. So it will print, what will be the new value of I here? 2. Instead of making it too long, I will reduce it to 5. Clear? So new value of I here is 2. Again it goes on the top. Is 2 less than or equal to 5? Yes. Then it will print the value of I, which is 2. Then I said I's new value is 2 plus 1. What will be the new value of I? 3. Again it goes on the top. Is 3 less than 5? Yes. It will print the value of I, which is 3. Now it becomes 3 plus 1, 4. Is 4 less than or equal to 5? Yes. Again it prints the value of I, which is 4. Now it becomes 4 plus 1, 5, which is the new value of I. Again it goes on the top. Is 5 less than or equal to 5? Yes. It prints the value 5 here. Then it becomes 5 plus 1, 6. This is the new value of I. It goes on the top. Is 6 less than or equal to 5? False. The moment it is false, the statements after done would be executed if there are any. In my program, there is a statement. This is the last line. So iteratively, the statements that you mention between do and done are executed. These are the statements. Repeatedly, those statements are executed. How long? Until the condition that you have given with the while loop evaluates to true. So as long as it evaluates to true, whatever statements are there between do and done, they would be repeatedly executed. Now using the same logic, I can apply it to the command line arguments. As long as there are command line arguments available, keep on adding them. So every time in a loop I will use a shift as long as there are command line arguments available, and I can keep on doing the addition. Let's run this program and test this out. See here. So it printed 1, 2, 3, 4, 5, which are the statements outcome between do and done. And once the condition evaluated to false, it will start executing statements in your program which are after the done statement. If there aren't any statement after done, done was the last statement, obviously it won't execute anything. The program will come out. I have commented that now. So the loop terminates the moment the condition evaluates to false. If there are any statements after the done statement, it will start executing them. If there aren't any statements after that, the program itself would terminate. So performing repetitive actions in a programming style is what is called as looping constructs or loop constructs, or this is also called as an iterative action. So you want to do something iteratively, monotonously. How long? As long as the condition evaluates to true. So see here, I am writing infinite while dot sh. I said while true, do echo that's it. So what I have given in the condition? True. Is there any chance that my condition will evaluate to false now? I have hard coded use a literal called as true. So it will always be true. And then statements between do and done will be executed. Is there any way to end this thing? No. That's why I am calling it as a infinite loop. Infinite means there is no end to this. See here, it's still running. It's so fast that it is not allowing me to scroll. Then I press Ctrl C. At some point in time I will have to terminate it by pressing Ctrl C. There is no way my condition will evaluate to false and my loop will terminate. So if your loop is forever perpetually going on, that means there is something wrong with the loop that you have written. Remember, writing perpetual loops like this will consume 100% of the CPU of your machine. If it is something like this. So I am modifying it, at least it provides me some time for reaction. So I said with every time sleep 1, so that at least I can go and press Control C. Otherwise it's too busy in executing those actions repeatedly. So I said running this, running this, running this. Now there is a 1 second of a delay in between. At least now I can go and press Control C. Otherwise it runs so fast that even Control C at some point in time it will take a long time to acknowledge that Control C, because it's too busy executing the print statement. 100% CPU occupied. Clear? So while we'll keep on running the statement. So understand, iterative constructs or also loops, while loop allows you to perform some action iteratively as long as the condition associated with the while loop evaluates to true. As long as it's true, it will perform that action repetitively. It will break only when the condition evaluates to false. How to write it? While followed by some condition in square brackets as part of syntax, do and done, and whatever you want to do repeatedly. So I want to perform some action repeatedly. For example, I said I equal to 1 while I less than equal to 5, print hello, echo the value of I, increment the value of I by 1, go again on the top. So it will print hello 1, hello 2, hello 3, hello 4, hello 5. The moment it prints 5, the value of I is 5 plus 1, 6 is the new value. It goes on the top. Is 6 less than or equal to 5? No. It will come out and it will run the statements, if any, after done in your program. So I have a statement, the end of the program. Clear? So understand the iterative actions to be performed by the while loop. The condition in some cases would always be true and it would result into an infinite loop. I said while true, condition itself I have evaluated to a static value called as true. And then I said print this message, sleep 1 done. So it will keep on printing that message forever. It will never come out until you terminate the loop by pressing Ctrl C or by using the kill command and pass signal 15 or signal 19, sig term or sig kill to the program to kill that particular program. Otherwise there is no way that program would come out on its own. People say how long it will run? Well, if it's an infinite loop, it will run until the doomsday, Qayamat tak. People say what is the Qayamat tak? Is it you are referring to Quran? Well, I am not referring to Quran here. I am referring जब तक CPU पिघल ना जाए तब तक. Execute करते करते समय एक टाइम ऐसा आएगा that machine will reboot itself after too many hours, obviously, because it will become so hot executing it. If the temperature rises, the machine will automatically reboot. Clear? So don't run it infinitely until there is some meaning to run it. Well, that's all about for loop, and that's all for this session as well.